Hello everyone, welcome to our channel Helm of Science. I hope that all of you are doing well and studying hard. So today I will start a very important and interesting chapter of class 11, and that is redox reactions. Now this chapter carries a significant amount of marks in your board exam as well as in your competitive exams like JEE, NEET and other exams. So without any further delays, let's get started. So what at first we need to know what is redox reaction. Now redox reaction, it is a class of chemical reaction in which oxidation and reduction, that is oxidation and reduction, occurs simultaneously. Occur simultaneously. Okay, that means they both are taking place at the same time. Now there are various types of examples that take place via these oxidation reduction reactions. Suppose for the production of, you can say, chlorine, or by the photosynthesis process that we witness in nature, that is the plants that exhibits photosynthesis. That process is also an example of this oxidation reduction reaction, or you can call it as redox reaction. So now in this case, since it is related to oxidation and reduction reaction, at first we need to have a small idea about oxidation and reduction. We all know in our junior classes that oxidation oxidation refers to loss of electrons. Loss of electrons. Now this loss of electrons can be from an atom or from a cation, that means a positively charged ion, or it can also be from an anion or by a molecule. Suppose I am considering an atom, sodium atom. Okay. Now, when it will lose electron, it will form Na plus, that is sodium plus ion, and it will release one electron. So this we can call it as oxidation reaction. Similarly, for a cation, suppose this is our ferrous ion, it will lose one electron, it will form Fe3 plus ions, that is ferric ions. Okay. Many other examples are also there. Suppose for an anion like iodine, that is iodide ions, it will lose electrons to form iodine. Okay. And finally, if we talk about a molecule, suppose hydrogen molecule, so it will lose electrons to form H plus ions. So these all are examples of oxidation. That means all these reactions, they involve loss of electrons. Understand? Next, we will discuss about reduction. Reduction is just the opposite of oxidation. Reduction means gain of electrons. That means it will gain electrons. Now again, this gain of electrons can be from an atom, from a molecule, from a cation, or from a molecule. Okay, so let's take an example. Suppose if I consider chlorine atom. Okay, this is chlorine atom. So when it will accept one electron, what will it form? It will form Cl minus ion, that is an anion. Okay. Similarly, if I take oxygen atom, it will accept two electrons and it will form oxide, that is 2 minus O2 minus ions. Similarly, if you take an example such as Fe3 plus, that is ferric ion, it will accept one electron and it will produce Fe2 plus, that is ferrous ions. So these all are examples of reduction reaction. Okay. Now, talking about this electronic concept, there are very familiar two terms that we have learned in our junior classes. Let's also revise it once more. The first term is oxidant. Okay, now what do you mean by this term oxidant? Oxidant are the species, they are the species that itself get reduced, itself gets reduced and oxidizes others. That means it will oxidizes other substances, you can say. So this is the basic definition of an oxidant. That means in a reaction, it will get reduced. It itself will get reduced and it will oxidize another substance. Okay. So this is called an oxidant. Now there are various examples of oxidants. Examples are, suppose hydrogen peroxide, H2O2. This can be an example. The halogens, the several halogens, they are the examples of oxidants. Fluorine, chlorine, bromine, iodine. So these are the examples of oxidants. There are many of them. I've just mentioned a few of the oxidants. Now we will discuss another term, that is reductant. What do you mean by reductant? So reductants, they are basically the species that itself gets oxidized, they will itself get oxidized and reduces other substance. That means it is just the reverse of an oxidant. That means in a reaction, these species will get itself oxidized and they will reduce another substances. Now their examples are many, such as all the alkali metals. Alkali metals, okay, they are reductants. Alkali metals means sodium, potassium, rubidium, cesium, etc. Okay, the alkali metals, they have a strong tendency to lose electrons. That means they will itself get oxidized and will reduce other substances. So we can call these alkali metals as reductants. Other examples are also there, like hydrogen, H2S, that is hydrogen sulfide, okay, and many others, etc. Okay, so these are the examples of reductant or reducing agents. Okay, next we will explain this nature of oxidant and reductant with the help of a reaction. Okay, I'm first writing a reaction, that is 2K plus, this AQ means it is in aqueous state. Okay, plus 2I minus aqueous plus Br2 liquid. Okay, and this is giving me 2K plus again in the product side, it is aqueous, plus 2Br minus, this is also aqueous, plus I2, that is solid. This is my solid compound. So if you see carefully here, at first iodine was present as I minus. Iodine was present as I minus. Now this I minus, this has lost electrons and has formed I2, that is solid iodine. That means I minus has lost its electrons to form I2. Okay, that is by losing electrons. And on the other hand, this bromine has accepted electrons to form bromide ion. Okay, so accepting electrons means reduction, and losing electrons is oxidation. So I can say that formation of I minus to I2, it is a type of oxidation. Okay, this is oxidation. And formation of Br2 into bromide ion, this is reduction. Okay, so what I can conclude from here is I minus, that is iodide ion, here behaves as behaves as reductant. That means it gets oxidized itself and it reduces another one, another substance. That is, it has reduced bromine. And on the contrary, this bromine, that is Br2, it behaves as oxidant. Okay, that means bromine has reduced itself to bromide ion, and it has helped iodide to get itself oxidized to iodine. So with the help of this equation, or rather this reaction, we can get a clear idea about oxidant and reductant. Okay, now we will witness a reaction where oxidation and reduction occurs simultaneously. That is, oxidation, reduction occurs simultaneously. Okay, so we will just take one example to understand this. Suppose, let us take one example, that is zinc, this is in solid state, plus CuSO4, that is copper sulfate. Zn plus CuSO4, this is in aqueous condition. This will give zinc sulfate, that is ZnSO4, it is in aqueous state, plus Cu in solid. So this is my reaction. Okay. Now, here, if I break them into ions, what I will get? This will remain like this, plus Cu2 plus SO4 2 minus. Okay. Now I can here write Zn2 plus SO4 2 minus plus Cu. Okay, so I have just break the CuSO4 compound into two different ions, the cationic part and the anionic part. Now, if you see carefully, zinc has lost its two electrons to form Zn2 plus ions. Okay, that means zinc to Zn2 plus ion, this is oxidation. Why? Because it has lost two electrons. I can write in this way, that is zinc, it has lost two electrons to produce Zn2 plus. Okay, so this is the oxidation reaction. And if you see that this copper Cu2 plus, this gets reduced to metallic copper. That means this Cu2 plus has accepted two electrons to produce copper. So this is the reduction reaction. Okay. Always remember then that increase in the oxidation state that we will discuss later, increase in the oxidation state will produce oxidation, and decrease in the oxidation state or oxidation number will give you reduction. Okay. Up to this, I think it is pretty much clear to you all. Now, we will come into a new term, that is half reaction. Half reaction. Now, what does this half reaction means? Basically, a redox reaction is divided into two half reactions. A redox reaction is divided into two half reactions. One is the oxidation half reaction and another one is the reduction half reaction. These two half reactions combine to give a total redox reaction. Okay, so we will just discuss the above example in order to understand this concept. Suppose I'm again writing Zn solid plus Cu2 plus. This is giving me Zn2 plus Cu. Okay. So as we have already discussed that Zn from zinc solid to Zn2 plus, it is oxidation, isn't it? So I can write my oxidation half cell like this. My oxidation half cell will be zinc solid. It has lost two electrons to form Zn2 plus aqueous plus twice E. So this is my oxidation half cell or half reaction, whichever way you want to tell. And my reduction half cell or half reaction will look like this. Cu2 plus in aqueous state, it will accept two electrons to produce, Cu solid Cu. Okay, so this is my reduction half cell or reduction half reaction. So if you combine these two, you will get the original reaction, that is zinc solid plus Cu2 plus, that is aqueous. It will again give you Zn2 plus aqueous plus Cu, that is my solid. So in this way, a redox reaction can be represented into two types of half reactions or half cell. One is the oxidation half cell, another one is the reduction half cell. Okay. Next, we will discuss about oxidation state. Okay, oxidation state. What do you mean by this oxidation state? Oxidation state is the oxidation or reduction of an element that is present in a compound. Okay, that means when I'm telling, suppose I'm taking an example, suppose CuCl2, okay, cuprous chloride. In this case, in this compound, Cu, that is copper, Cu will exist as Cu2 plus. Okay, so I can say that the oxidation state of copper in CuCl2 is Cu2 plus. Okay, similarly, if I say for NaCl, what will be the oxidation state of sodium? We will say that the oxidation state of Na will be what? Na plus. That means sodium will exist in its Na plus state. Okay. Always remember that for an element, cation will be the oxidized state. Cations will be the oxidized state. Okay. And anions will be the reduced state of an element. Understood? So if I say for NaCl, what will be the oxidation state, or rather I should say which one will be the oxidized state and which one will be the reduced state? So for NaCl, Na plus will be in oxidized state and Cl minus will be the reduced state. Okay. So this is all about the oxidation state. That means in which state does the element that is present in a compound will exist. That will define the oxidation state of that element. Okay. Next, we will discuss about oxidation number. Oxidation number. Now, oxidation number is pretty important. Oxidation number, it is basically a number, a definite number, which will give you the extent of its oxidation or reduction, okay, from an atom of an element from its free state to its bonded state. That means it will give you a fair idea about the extent of its oxidation or reduction. Now, in this case, if oxidation is the what I can say is the necessary effect for that change, then the oxidation number will always be positive. And when it requires reduction, then the oxidation number will always be negative. Okay. Now, in this aspect, you have to remember that the oxidation number of a molecule or atom in its free state is always 0. Okay. If I talk about only zinc, that means it exists as in its free state. So for zinc, the oxidation number will be equal to 0. Okay. But if I say ZnCl2, here the oxidation number of zinc will be equal to how much? It is +2. Okay. Oxidation number of zinc chloride will be equal to +2. Now, for calculating the oxidation number of electrovalent species, to determine the oxidation number of an electrovalent species, that will be equal to the number of electrons that it will lose or gain during the formation of an ionic compound. Okay, we will discuss with an example. Suppose this is my NaCl. Okay, NaCl. So during the formation of ions, what will it produce? It will produce Na plus and Cl minus. So here we can see that the number of positive charge in sodium is only 1. That means it has lost only 1 electron to produce the positively charged cation. Whereas for chlorine, it has also lost one of its electron to form chloride ion. So we can easily say that the oxidation number of sodium is equal to +1, and for for chlorine it is equal to -1. In this way, you have to determine the oxidation number. Similarly, if I talk about another example, that is FeCl2. Okay, FeCl2, if it forms ions, what will it produce? It will produce Fe2 plus and Cl minus ions. Okay. So by seeing their charges, we can easily say that oxidation number of iron here is equal to +2, and for chlorine it is again -1. Okay, so in this case we can frame many examples and we can be able to determine their oxidation number. Now these are all for the electrovalent species. Now what about the covalent compounds or covalent species? If I talk about the covalent compounds, for covalent compounds, the oxidation number in a covalent compound, that is, I will explain you with an example, that will be equal to the number of electron pairs that the atom shares with one or more atoms of different electronegativities in the compound. That means here it will be equal to the electron pairs that will be shared that will be shared by an atom with one or more atoms of different electronegativities. This parameter is very important, of different electronegativities. Okay, so let us discuss this with an example. Suppose I am taking one example, that is HCl. HCl molecule is formed via covalent bond formation between hydrogen and chlorine. Now we all know that electronegativity of chlorine is greater than hydrogen. So what we can assign from here is hydrogen will carry some delta positive charge. Delta means it can have any charge. That means for HCl, this del value will be equal to +1. Okay, and Cl will carry some sort of a del minus charge. That means negative charge. And for HCl, this del value is equal to -1. So what we can tell from here is in HCl, the oxidation number of hydrogen is +1, and for chlorine it is equal to -1. Okay. Similarly, if I consider another example, that is water, what happens in case of water? In case of water, oxygen atom will share two of its electron pairs with the two different hydrogen atoms. That means oxygen here, it will share one of its electron pairs with one hydrogen atom and another one with another hydrogen atom, and it will form like this. So I can say that oxygen will carry -2 charge, isn't it? As oxygen is more electronegative than hydrogen, and hydrogen will carry +1 here and +1 here. And as a whole, as it is a neutral molecule, its total charge will be equal to 0. So H2O will look somewhat like this. Okay, oxygen here, the oxidation number of oxygen will be equal to -2, and oxidation number of hydrogen will be equal to +1. Okay, let's take another example. Suppose let's take an example of CO2. What happens with CO2? Here, carbon will also share its electron pairs with two different oxygen atoms. That is, it will be somewhat like this. It will be a double bonded oxygen. So what I can say, it has shared four of its electron pairs. So it will have 4 delta plus. That means it will carry 4 delta plus charge. And here, for two oxygens, they will carry 2 delta minus charge each. So I can say from here that oxidation number of carbon will be equal to +4, and for oxygen, for each oxygen, it will be equal to how much? It will be equal to -2. Okay, so in this way, you have to find out the oxidation number in case of covalently bonded compounds, covalent compounds. Okay, now there are certain rules while writing or calculating the oxidation number of an element. Now, the first rule that I have already told you, that if the element exists in its free state, that is free state element will have zero oxidation number. That means if an element exists in its free state or in its elementary state, it will have zero oxidation number. Okay. Second one is, if for monoatomic ion in an ionic compound, their oxidation number will be equal to its charge. That is, for monoatomic ion, the oxidation number will be equal to its charge. Let's take an example to understand this. For example, in FeCl2 ferrous chloride, here iron and chlorine exists as Fe2 plus and Cl minus ions. We have seen this. So we can say that the oxidation number of iron is +2, and for chloride ion it is -1. That is, for chlorine the oxidation number is -1. Okay. Now there is a very important rule, that is the algebraic sum of the oxidation numbers of all atoms in a neutral molecule is 0. Okay, that means if you take a neutral molecule, okay, neutral molecule, suppose if I take an example of FeCl3, in case of FeCl3, the oxidation number of iron is +3. Okay, this is for iron, and for chlorine it is -1. So if I am to determine the oxidation number of ferric chloride, that is FeCl3, what will I see? Iron will carry +3 charge, and along with iron there are 3 chlorine atoms having chloride configuration, that is 3 into -1. So you will get 3 minus 3. As a result, it will give you 0. That means it is a neutral molecule having oxidation number equal to 0. Okay. Now, hydrogen, generally for metallic hydrides, the oxidation number of hydrogen is always -1. Okay, -1 will be the oxidation number for hydrogen if it exists as metallic hydrides. Suppose for NaH, sodium hydride or calcium hydride, here the oxidation state of hydrogen will be -1. Okay, but for other hydrogen containing compounds except these metal hydrides, the oxidation number of hydrogen is +1. Okay, that means if I take a NH3, suppose NH3 suppose H2O, or you can say for H2SO4, all of these compounds will have +1 oxidation state, +1 oxidation number of hydrogen. That is, as they are not hydrides, the oxidation number for hydrogen will be always be +1. Now, oxidation number of oxygen will be -2. You have to remember this. And for all fluorine containing compounds, they will have oxidation number of -1. Okay. And there are some elements which will show some fixed value of their oxidation number, such as the alkali metals. Alkali metals like lithium, sodium, potassium, rubidium. Okay. They will always show +1 oxidation number. That means their oxidation number won't change. It will always remain as +1. Also for alkaline earth metals. Alkaline earth metals like beryllium, magnesium, calcium, strontium, and others, they will always exist in +2 oxidation number. Okay. Similarly, there are some other elements like for zinc, it will always exist in +2 oxidation state. For aluminium, it will always exist in +3 oxidation states. So these are some of the rules for writing or for calculating the oxidation number of an element. Now, there are certain ions which have got some definite value of their oxidation numbers, such as for sulfate ions, SO4 2 minus, their oxidation number is -2. Similarly, for nitrate, that is NO3 minus, their oxidation number is -1. For NO2 minus, their oxidation number is also -1. Similarly, OH minus will have -1 oxidation number. For say NO plus, they will have +1 oxidation number. And for cyanide, Cn minus, they will also have -1 oxidation number. So these are some of the ions which have some definite value of their oxidation numbers. Next, we will calculate the oxidation number in some compounds. Okay, that means for some elements which will be marked with an asterisk, and you have to find the oxidation number of that element. Now we will calculate the oxidation number in some compounds. Calculation of oxidation number. Okay. Suppose you are given a compound, say H2SO4. You are to determine the oxidation number of sulfur. So how will you determine that? So for that, we at first have to consider the oxidation number of sulfur to be X. Okay. Now in H2SO4, we all know that the oxidation number of hydrogen will be +1. So +1 into how many number of hydrogens are there? 2. So +1 into 2 plus, for sulfur we have taken it as X, so it will be +X plus, for oxygen the oxidation number will be how much? -2. And how many oxygen atoms are there? Into 4. Now, as I already told you that for a compound in its neutral state, the algebraic sum of all the oxidation number will be equal to 0. Hence, we are putting 0 in the right hand side. Or +1 into 2 means +2 plus X plus 4 into -2. It will give me -8. It will be equal to 0. So by solving x, you will get 8 minus 2, that is equal to plus 6. That is oxidation number of sulfur in H2SO4 will be equal to plus 6. Okay. If I consider another example, suppose K4 FeCN6. Okay, I have this compound, and you have to determine the oxidation number of iron. Okay, you have to determine the oxidation number or oxidation state of iron. So how to determine this? Now we have to just consider the oxidation number of iron as x. Now K, that is K means it belongs to alkali metals, and from the rule we know that alkali metals will have oxidation number plus 1. So plus 1 into how many K atoms are present? 4. So plus 1 into 4 plus x, that is for iron we have considered it as x, plus for cyanide we have discussed its atomic number is minus 1, and total number of cyanide ions present is equal to 6. Okay, so and for this neutral molecule we know that their algebraic sum will be equal to 0. So 4 plus x minus 6 equal to 0. Hence by solving x we will get 6 minus 4, that is plus 2. So we can say that the oxidation number of iron in K4 efficient 6 will be plus 2. And coming on to the last example of today's class, that is Kcl O4. Okay, Kcl O4. You have to determine the oxidation state of chlorine in this compound. So again, we have to consider the oxidation number of chlorine equal to x. Now, potassium belongs to alkali metal group, so it will be plus 1 plus x plus oxygen has oxygen has oxidation number of minus 2, and total number of oxygen atom present is equal to 4. And as it is a neutral molecule, so we will have 0 as their algebraic sum, or plus 1 plus x minus 8 equal to 0. Hence by solving we will get x equal to 8 minus 1, that is equal to plus 7. So the oxidation state of chlorine in KClO4 will be plus 7. Okay, so I'm stopping the class right now. There are some exceptions to the calculation of oxidation number in case of certain compounds that we will discuss in the next class. So I hope that all of you have liked the video, and if you did, then do like and share the video and subscribe our channel Helm of Science. And if you have any doubts regarding the topic, you are free to ask me in the comments box. Okay, so we will meet in the next video. Until then, keep studying and stay safe. Thank you.